So I own a plant called Sal. She sits on my windowsill and is, only just clinging to life at the moment. The thing I don't get is that I water this thing religiously and yet she still looks to be on the verge of death all the time. What could I be doing wrong?
Some sort of clue!
The answer is simple. I haven't over-engineered the watering process. So instead of just Googling what the problem is, I'm going to make a system that can automate watering the plant so that I do not have to. I am the Elon Musk of tree care, which I'm not sure if that's good. So here's the brief. I'd like to be able to handle the entire Sal watering process from my desk, which is on the opposite side of my room from the window. I'm a busy person, I have a full-time games industry job, and so I don't have the space in my schedule to get up and walk 5 seconds to the other side of the room to use a spray bottle for half a minute. No. Those cryptocurrency microtransactions aren't going to implement themselves. The upshot of that for the Sal watering project, or SWP as I'm calling it, is that there needs to be a way for me to send a signal to a plant watering setup on the other side of the room from my desk. I think the easiest way of doing it would be to put a button on my Stream Deck, and when I presses it, my setup just waters the plant. On the plant side of the room, we need a central server that can listen to those requests, and that server then sends an electrical impulse to a pump situated in a body of water that then drives the water into the pot, watering the plant, and meaning I didn't have to get up to water my tree. Yet another brave and inspiring innovation from Gowland Tech Industries. There's just one problem with all this, and that's that I've never tried to program hardware before. How hard can it be though, I thought, before realizing that actually it was quite difficult. Anyway, fortunately I had a Raspberry Pi from forever ago locked away in a drawer somewhere because I meant to use it and then never got around to it. I think it's the Pi 2 Model B, I don't know, it's all green plastic anyway. So the first step is to see if we can get the Raspberry Pi to power something. I found a bag full of like small LED lights designed for breadboards and small projects like this and whatever, and that felt like the perfect starting point. However, at this point all I had was the board and these lights with no way to link them up. So I went to this website, the Pi Hut, which sells Raspberry Pi boards and accessories and stuff, not sponsored, and ordered stuff to set up my prototype. I also bought the stuff I thought I'd need for the final product, but I'll let you know how that went in a second. So among other things, I got this half-size breadboard and a bunch of jumper cables in all 3 potential configurations, and got to work setting up my light. For those of you who didn't pay attention in GCSE physics and Lamau same, your power supply and the thing you want to power both have 2 ports, the positive and the negative end. This was way more hassle than I anticipated. On the light side, the LED has 2 legs, an anode and a cathode. The anode is the longer one and is the positive end, and the cathode is the shorter side and is the negative end. I didn't bother to Google this before just jumping into it, and so I got real mad at myself when it didn't work even though the solution was ridiculously basic. It was the Raspberry Pi side that proved the more challenging though. On a Raspberry Pi board you have this line of pins called GPIO pins, and you can use them to output electrical signals to power external peripherals. In this case I want to send an electrical signal to the light to make it switch on, so I need to connect the anode of the light to the positive pin and the cathode to like a grounding pin. How do you tell which pins are which? I don't know, through like magic or something. Okay, no, it's not as obtuse as that. These Pi boards come with diagrams called pinouts, which tell you what the numbers of all the pins are and what they all do. This pin here, for instance, is the grounding pin I'm going to use to handle the negative current from the cathode, and this pin is the positive pin that's going to send the signal to the anode. They also have numbers attached to them in code, which means if we get into the Pi and tell it to send electrical signals to a certain number, we can set this circuit up. Here's the code if you care even the slightest amount, but we live in a society. Basically, we're importing the GPIO library in Python and then outputting a signal to this port. After not needing to diagnose a million different issues with the system, it worked on the first try. Using a for loop, I even got it to blink a specified number of times, which is rather neat, I would say. This probably doesn't seem that impressive, but I got very excited by it given I've never even tried hardware stuff before, so everyone has to be nice to me. Speaking of being nice to me, did you know that only negative 12% of you are subscribed to this channel? Anyway, having walked like 30 centimeters, it's time to run a marathon. And the marathon in this analogy is the pumping system. We're going to hook up the pump I got off the Pi Hut in the place of the LED, and it's going to work on the first try, and okay, it didn't work. For some reason, when I hooked up the Raspberry Pi to the breadboard and plugged the wires for the pump into the same place the LED had gone, nothing was working. At this point, I was sort of just staring blankly at this pile of random electronics on my shelf, wondering where on earth my life had gone wrong, when it occurred to me that maybe someone else had been in this situation before and that I could, like, look it up. So I looked it up, and as it happens, the pump I bought is actually just a DC motor in a plastic case with a couple extra bells and whistles. This combined with a few visits to Stack Overflow confirmed the problem. I hadn't bought enough stuff. Turns out the Raspberry Pi board doesn't output enough power from its GPIO pins to spin the motor, like, at all. What I needed was 2 additional components, a battery pack with enough voltage output that the motor would spin, and a small chip called a motor driver. As I said, I don't want the motor to just be spinning all the time because then I would be going back and forth to the shop buying batteries all the time. I want the motor to start spinning while I send the signal to my web server on the Pi. What the driver does is it listens for an input signal before sending the electrical signal from the batteries to the motor. So I sucked it up and I bought the motor driver driver and the battery pack. The driver was really small, this tiny chip with like 8 arms sticking out, but if you slot it over the gap in the breadboard, then the input from the Pi can go in on this side, and the stuff from the batteries can go in on this side, and you don't get any crisscrossing nonsense which would break everything. This tiny bitty thing also came with a pinout which was more complicated to pass than I anticipated. To be honest, when I looked up motor drivers online, I saw all these terrifying pictures of wires hanging around all over the place and all the rest of it, and that alone made me want to give up. But I have a trio on the cusp of meeting God here, so, you know, needs must. So I played around with it for a while, and I was able to actually get the motor to spin up from the battery pack and start sending water into the plant pot, which was great, but it wouldn't, stop. Like, I get maybe I'm not watering the plant enough, but I feel like if I just left this running, I would drown her. That or I would run out of battery. This doesn't meet the brief because I only wanted to emit water when I tell it to. So there I was, on the cusp of success, but not sure how to make the final step. It was at that moment, though, that I had a critical brainwave. I had to turn my way of thinking around. Instead of thinking about how to make the motor driver work, I had to think about what bad decision I'd taken that had caused it to not work. This was a big moment for the project because then I remembered I'd got the legs of the light the wrong way round, like earlier when we were doing the prototype, right? And I wondered to myself, have I put the wires into the motor driver right? The answer was no. Because of the way the motor driver is aligned in my breadboard, I'd got my perspectives mixed up and plugged the input and output from the battery in the wrong place. The battery was sending a forward signal to the motor, and so it was obviously going to just spin and spin and spin because it thought I was telling it to. Just shifting the wires around fixed the problem, and now it would only send water to the pot when the right GPIO pin outputs an electrical signal. Success! To interact with the watering process, the Raspberry Pi starts up a Node.js web server when it gets switched on that listens for what's called a post request, a type of request sent to a website that also transmits some data. This is useful on the internet because you maybe want the page to change based on what user is logged in, for instance, but in this case it's useful because it can listen for a post request containing a specific keyword in order to transmit the watering command. This one uses the Node on-off library, which interfaces with the GPIO pins to send the command to the pump while listening for the keyword on. In order to send the on command to the Pi, we need a way to send post requests from my computer to the board. On the command line, you can do this from a curl command, curl being short for client URL. Curl lets you send and receive data using HTTP style syntax, which is perfect for us because it means we can send on and a post request that the board understands. But how do we get the Stream Deck to use that command? Lucky for us, we can create rudimentary command line applications that use this exact syntax by creating what's called a batch file. I couldn't think of appropriate stock footage to go here. A batch file is basically just a text document with a list of commands to be executed in the command line. You see, the joke here is that I stretched out the text and then I added a which is brilliant for this because we can just lift the exact terminology we were using a minute ago into a notepad document and then link the Stream Deck system open action to it. This joke was barely funny the first time, but because I'm lampshading it not being funny, it wraps back around to being funny. Now when we press the button, the system waters the plant. So that's how I revolutionized and technologized plant watering, a process that is truly so basic and pointlessly simple that it takes the average breathing creature about 10 seconds into a needlessly complicated system that uses a web server, nearly £40 worth of electronic components, and a device mainly intended for live streamers. Was it worth it? Not really, especially given I've started using this plant feed mix, which because I've only got one Raspberry Pi, I still have to administer manually, so at this point I kind of have to ponder why I even bothered.